Okay, so here I'm just ranting, so you can ignore this. I mean, because I have graduate students, I've seen horrifying things, so I try never to look at their codes, and I try to do my own calculation every so often to keep sane. I do have coding tips, and I've learned from the masters. I myself, I've actually written, algebraic language for my PhD thesis, so I have done horrible things in my life as far as coding is concerned, but I'm not the master, but the masters are very amazing. So I have a colleague called John Gibson, with whom, or, thanks to whom we can solve Navier-Stokes equations to the precisions that we need. And here is how John Gibson works. So this is my hygiene tips. John Gibson has a pencil, and he has a notebook, which I don't have here, paper, with a square on every page. And he said the way we solved Navier-Stokes is, I talked and talked and talked, but John Gibson wrote on this paper what the program should do. That took actually 3 months, writing out what he's supposed to compute. This was done by pencil on paper and by thinking. Once he was finished, and I swear I was there, it's true. Once he was finished, he sat down and spent a day typing it in. Then he pressed start, run, and out of it came 3 solutions of Navier-Stokes equation that no human eye has set foot on before. There was no fixing the code because there was some bug or some other bug, because fixing the code is incredibly inefficient. Wasting 90% of your intellectual effort in finding some stupid bugs in your code costs you so much in the long run that it's not only unhygienic, but it's suicidal. You'll never get there. So that's my tip, hygiene tip.
What was in the notebook? Everything?
Navier-Stokes equation, you write them as 2 sets of Fourier modes because they're translational direction, and then Chebyshev modes in the whole normal direction. So these are all expansion of kinds. We will do more because we'll do some Fourier modes later on. So you get, algebra of objects which have 3 indices because they're in 3 dimension, and, one of them is streamwise, spanwise, and one is wall normal. For this particular problem, it's a fluid between 2 walls. And you go on, and then you say, I have to put this on computer. So I write this module, this module, this module, and then I call this, and so that's what a notebook is, 20, 30 pages of thinking, erasing, rewriting, trying to do it efficiently. And it's equally important in terms of salary. He has been paid, I don't know, some amount of money per month, not very large amount of money. The cost of him is comparable to the cost of computers, but he's more important than computers because computers cannot do anything without John Gibson. Yeah. So the importance of thinking in modern computing is often underappreciated. It doesn't help that you can buy 1,000 cores instead of 6 cores for what it costs only 10 times much as compared to something. It doesn't do anything unless you have hygiene.